When you create a cost-risk model with a schedule overlay and acumen risk, the effect of your schedule delay is included in the cost analysis. Here we'll explore this. Schedule delays have the effect of increasing labor and equipment costs. As the schedule extends, you must continue to pay for your labor to do the work. Also, you must continue to rent the equipment. Material costs, however, are not dependent on schedule duration. They are a one-time cost to acquire and have no ongoing related costs unless you have storage fees. We have our demonstration of an acumen risk schedule. We generate a cost risk model with a schedule overlay from our schedule risk model. Acumen creates a cost risk model that includes a schedule overlay without a copy of the risk register. This figure displays the resulting navigator pane, with a Mars Probe 2020 U2 schedule risk model and a Mars Probe 2020 U2 cost risk model. In this figure, we first select the Mars Probe 2020 U2 schedule risk model in the navigator pane. Second, change its description to read Mars Probe 2020 U2, and third, click the original project name field to generate a new name for the schedule risk model. Here shows the resulting navigator pane with both SCH and cost risk models. We proceed and import an Excel cost risk register for the cost risk model. The resulting cost risk model with risk register is displayed in this figure. Now that we have both our schedule model with a risk register and the cost model with the recently imported risk register, we are ready to begin our analysis to demonstrate the effect of schedule overlay on the uncertainty cost of our demonstration schedule. We begin by selecting the Mars Probe 2020 U2 SCH model in the navigator pane, then adjust the duration uncertainty slider to turn off duration uncertainty for the entire project. We proceed by confirming the selection of the Mars Probe 2020 U2 SCH model in the navigator pane, clicking the bottom portion of the Run Risk Analysis button, and choosing the Uncertainty Only, No Risk Events scenario. We first confirm the schedule risk model is selected in the navigator pane, second, select the top-level project deliverable, and third, click the top portion of the Run Risk Analysis button. Note that selecting the top-level deliverable at this time may not be necessary. Still, it is a good practice to keep, as later in the cost model, adding the correct deliverable plot to the risk exposure comparison is essential. This figure displays the resulting histogram, which consists of one date, the critical path method completion date. In the navigator pane, select the cost risk model and adjust the uncertainty duration slider to realistic, as shown in this figure. It is my practice to consider always the estimator's cost estimates realistic. Next, in this figure, we select the cost risk model in the navigator pane, choose the bottom portion of the Run Risk Analysis button, and set the scenario to Uncertainty Only, No Risk Events. Here we confirm the cost model selection in the navigator pane, choose the top-level project deliverable, and choose Run Risk Analysis. After the analysis is computed, confirm that the cost model is selected in the navigator pane, choose the top-level project deliverable, confirm that the S-curve plot is for the project deliverable, and click Add to Risk Comparison. Again, it is important to make sure you have the correct deliverable selected at this juncture before adding its S-curve to the risk exposure comparison. Click OK to copy the S-curve to the risk exposure comparison. Select the schedule risk model in the navigator pane, and adjust the duration uncertainty slider to aggressive. Confirm the selection of the schedule risk model in the navigator pane, choose the top-level deliverable, and click Run Risk Analysis. Here we displays the resulting histogram and S-curve for the schedule risk model, which has a classic S-curve. We confirm the cost model selection in the navigator pane, choose the top-level project deliverable, and choose Run Risk Analysis. Again, note in the figure that the cost uncertainty is realistic. After the analysis is computed, confirm that the cost model is selected in the Navigator pane. Choose the top-level project deliverable, confirm that the S-curve plot is for the project deliverable, and click Add to Risk Comparison. Click OK to copy the S-curve to the risk exposure comparison. We proceed and choose Right Panel Risk Exposure Comparison to generate a graph of the S-curve plots. The risk exposure graph is plotted in here. Note the nomenclature for each plot identification. DUR off cost UNC real equates to duration uncertainty off and cost uncertainty realistic, and DUR ag cost UNC real equates to duration uncertainty aggressive and cost uncertainty realistic. It shows the variance selection between the two plots at the 80% cumulative frequency, i.e., 80% confidence level. The final graph is displayed in Figure 26, indicating that the schedule delay affected cost. The schedule duration uncertainty was turned off in the first plot above, so the cost curve was computed using the determinative schedule. This is equivalent to not including any schedule duration delay in the cost model results. In the second plot above, the schedule duration uncertainty was set to aggressive, which meant the estimator expected the project to meet the duration estimate or do worse. This second plot considers the effect of a schedule delay on increasing labor and equipment rental costs. One would not expect material costs to increase with schedule delay unless the project, perhaps, must pay for temporary material storage until installation. We see above that the schedule overlay has a noticeable effect on project cost at the 80% confidence level. Summary. The schedule overlay feature in Acumen Risk allows schedulers to factor in schedule delays on labor and equipment costs. After generating the cost model and importing the cost risk register, the scheduler can perform risk analysis on both the schedule and cost models. To reflect the impact of delays on costs, first run a risk analysis on the schedule risk model, followed by the cost model analysis. Ensure the same deliverable is selected for each run to make accurate comparisons. When conducting analysis, change only one variable at a time to maintain clarity in the results. Align the cost model scenario with the schedule model scenario to predict outputs more accurately and validate the results.